Okay, we're asked to differentiate 1 over x using the limiting chord algorithm. So we'll remind ourselves what the limiting chord algorithm is. That is, the function's derivative is equal to the limit as h approaches 0 of the function of x plus h, subtract the original function, divided by the difference in domain between the two functions. So basically what we have to do is we're just going to substitute this function into this algorithm and then do a little bit of algebra, and then we should come out with this function's derivative. Now, to start with, the function of x plus h, we substitute x for x plus h. So this is going to be equal to the limit as h approaches 0 of 1 divided by x plus h subtract the function, which is just 1 over x, all over again the difference in domain, h. Now that's a fairly scary looking fraction there, so what we're going to do is we're going to combine the two fractions in the numerator by multiplying their denominators, and then so we can actually combine our like terms at the end. So what we're going to do is we're going to have this is the limit as h approaches 0. Tedious, I know. This multiplied by this at the top, x multiplied by x plus h, is just going to be equal to x squared plus xh. Okay, now the numerators for this, x had been multiplied by x plus h to get to x squared plus xh. So we're going to times 1 by x. So it's going to be x subtract. Now the x plus h had to be multiplied by x plus h. So the 1 has to be then multiplied by x plus h. I'm going to put this in a bracket. That's just so we don't confuse our negative signs. And then all of this has to be over h. Cool. So now what we're going to do is we've got to move this basically into one fraction. So we're going to recognize that division is just multiplication by the reciprocal. So what we're going to do then is we're going to have the limit as h approaches 0 of, keep that bracket there, we'll combine our like terms up here. So we have x minus x plus h. So x minus x plus h is going to be, well, the x's will cancel, and we'll be left, this here will be left with negative h. So we're going to be left with negative h divided by x squared plus xh multiplied by 1 over h. Cool. So what you're hopefully going to see is that because we're multiplying this function with negative h in the numerator by another function with h in the denominator, these h's will cancel each other out, leaving negative 1 in the numerator. And so what we're left with is this is going to yield the limit as h approaches 0 of negative 1 over x squared plus xh. Now, once we've done that, we can then start fiddling around with the limit. So we're going to take the limit as h approaches 0. So we're going to write as h approaches 0, x squared plus xh is going to approach x squared. And as a result of that, the derivative is then going to approach -1 over x squared. So we can say, therefore, f prime of x is equal to -1 on x squared.